there are two more examples I would like to go over with you. Intentionally, I did not create the source code of them to provide to you. So you are encouraged to really try to put them into Eclipse for your own learning. Okay. If you got any trouble putting them into Eclipse, you can reach out to me, but at least try. The first one is about how you can, let's say in the try block, you actually call, let's say, bank.withdraw, which might trigger some invalid transaction exception if the amount is negative, right? And also we got circle.setRadius might also throw the invalid radius exception, right? So we are calling two lines of code inside a try block, which might trigger different kinds of exceptions. So now how do we use should we use a single catch block, or should we use multiple ones? I would advise use multiple ones. Each one of them will correspond to the kind of error you're expecting, right? In that case, we'll say catch negative radius exception. So this is with respect to this particular error that might occur, may or may not occur. And also another catch block will be invalid transaction exception. It's just in case if there's some exception thrown from the withdraw method. It's pretty easy. I just want to show you the syntax mainly. So you still got a try block. There's always only one try block to begin with. Associated with a try block, you may have as many catch blocks as you like, depending on how many kinds of error you're expecting to be thrown inside a try block. Let me just show you some test cases quickly. Again, since I didn't have the source code available for this example here, so if you want to try in the debugger, which I highly encourage you to do so, you should really put it into Eclipse by yourself. Okay, let's now take a look. I got two test cases. So test case number one, we have invalid amount for withdrawal. And for test case number two, we got invalid radius for calculating the area. Let's now try to trace that on the same block of code. I really want you to compare the execution flow. I'm going to highlight the flow as the lines that will be executed. Okay, let's now take a look. Let me start with test case number one. I'm going to use the blue to highlights. Okay, so let's now see this. So we're going to set the R to be some value. I'll fix that in a moment. And also assign the A amount to some value. In this case, it'll be 5,023,000, right? So 5 million will be the amount, and also radius will be 23. Apparently, the minus 5 million is invalid. We'll see exactly how that will impact the execution flow. After setting the two variables, we're going to enter the try block. And we'll initialize some bank objects. We'll add the account into it. And about how to really visualize this programming pattern that we already discussed in the tutorial series for the review, you can refer to them, or if you got any trouble, you can reach out to me about the programming pattern. And then we'll do some deposit over here. And then we're going to try to withdraw the amount. And the amount is actually minus 5 million, right? Over here. So that means minus 5 million, we'll expect this to trigger the invalid transaction exception. Okay, it's going to trigger invalid transaction exception, which is exactly over here, right? So we'll expect this exception to be thrown, and then it should really disrupt the execution flow, and then it will be caught by the matching catch block, which will be here, right? So what's going to happen is we're going to execute this catch block directly, whereas the rest of this part here will just be bypassed, right? So I can just make a note over here. So this part here is simply bypassed. And also the catch block over here that does not have the matching kind of exception is also bypassed. So we're going to execute the catch block, and then we'll say system.out_print_line to say some feedback to the user. And this is really important to see quickly. You can see once this invalid transaction exception is thrown to the catch block, we'll name that to E. You can think about E will store the address of this invalid transaction exception objects. And then we can invoke a method on E. And this is some method I would like you to try and then to see what it will contain. It's called the print stack trace. It will show you some more detailed information about this particular exception. Okay. After executing the catch block, we're going to go outside the try and catch block and execute whatever is remaining. So that's about the first test case. I hope you're okay. What about the second one? Let's say for the second test case, we're going to set the amount and also R to be these two values where the radius will be invalid in this case. So we're going to set R, and also we're going to set A. You can see some lines for these two execution flows will overlap, whereas some may not overlap. We'll see exactly. So the amount will be 100. So it's going to be valid this time, 100. The radius is going to be -5. So this is invalid, right? Let's see. We'll enter the try block, and then we'll still create the bank objects the second time. It's a different run. And also add the accounts, and also deposit. And now this time when we say b.withdraw over here, is it going to throw any exception? It seems like not, because amount over here is actually 100, which is valid. Okay, I'll put 100 here. So that one is not going to trigger the invalid transaction exception, meaning that we're going to go as like a normal flow. So we'll continue to the next line, which is going to create a new circle object. And now when we try to set the radius R over here, what's the value of R? That one is -5 over here. So this will be -5. And we can expect this to trigger the negative radius exception, which will match this first catch block over here. So you can think about this negative radius exception is going to be thrown and caught by this particular catch block. So what's going to happen is the remaining part of the try block will be bypassed. Okay, let me just draw a little bit more clearly. It will be bypassed, and also we're going to actually execute this particular catch block over here. Right? So we're going to execute this catch block, and then print out some feedback to the user, to the console, and also print this trace, print the stack trace for the exception. And after this, after the very first catch block that matches is executed, we're going to bypass the remaining part. So that means this part over here is going to be bypassed by the second test case. And after this, we're also going to execute the remaining part, if any, outside the try and catch block. Alright, so hopefully this comparison here really shows to you the difference between the two test cases. It's really important for you to understand how they work and how they're different. Okay, that's about the first example. And the other example I want to give to you, let me just show you some slides. Okay, it's about some useful library class that people actually make use of by using the exception handling. So you can look up the integer class in Java API, and then there is a static method. Let me haven't really reviewed static method just yet in this course, but we'll do that maybe a little bit later. But just to remind yourself from the first year, whenever you declare a method or an attribute being static, that means you can simply invoke it without creating a context object. You can simply say the class name, which is integer dot parse int. So that's the principle for static. Okay. And if you pass a string value over here, it will try to parse the string value input to be some integer. If you can do it, it's going to return back to you the integer. If you cannot do it, it's going to throw the number format exception. So now we can use this to actually program something with some tricky logic. Not really tricky, but it's just logical. For example, if you say integer, the class name, dot parse int, and then you're going to give the input value 23. So this string value here can be turned into integer value 23. You can see this is string value in the double quotes, and this is simply the integer value. So that's fine. What if I try to say integer.parse int? I'm calling the same method, but now I say in the string quote 23 in words. In that case, apparently this cannot be turned into a numerical value. In that case, you will simply throw number format exception. Okay? So now here is the exercise for you. Okay, can you write a fragment of code that prompts the user to enter a string using next line from the scanner, and then that represents an integer? And then if the user input is not a valid integer, then you will prompt the user to enter again. So you might need a loop, right? You can feel free to refer to the loops that I did in the earlier example. All right, so how would you do it? Okay, so that's about the exercise I would like you to think about. And before you see me going over the answer with you, I will recommend you actually pause the video and sketch some solution yourself, the loop and also the exception handling. All right, assuming that you thought about it, let's now go over the example together. Okay, we still have the Boolean attributes, the Boolean variable to control the entrance and exit for the loop. Let's highlight it. So we got some Boolean variable over here, valid integer. Initially, we haven't read any valid integer just yet. So that's why we put a negation over here and say valid integer. So not false. Initially, it's going to be true. So that means we'll go into the loop for at least once over here. And then when do we actually update this Boolean variable? We only update it when we are able to, okay, think about in this way. Okay, let me put some notes for you. It's really important. Okay, the logic is, you can see this is some method call over here. Let me just highlight it here. You can see this particular call, that's more like a call lead, right? This particular call may throw number format exception, which will match the catch block over here, right? If it is thrown, according to our definition, if this is thrown, if the number format exception is thrown, that means we'll bypass the rest of the try block and go to the catch block. That's going to be the disrupted workflow, disrupted execution flow. In other words, reaching this line, means the number format exception occur or did not occur. Did not occur, right? Because if it occurred, this line will be bypassed, as I said. Did not occur. And according to the definition for the method, as I just went over, if the number format exception did not occur, that means you were able to turn that string value input into an integer. So the implication is, that means the input string was successfully converted into integer. Converted into some integer value. All right, that's a very important logic you want to understand. Okay, let me say that again. This line may or may not throw the number format exception. In the case where it does not throw the number format exception, you will go ahead and go into the next line in the try block. In that case, we can say we have read the valid integer just in this line over here, right? So that's why we'll set it to be true. And the consequence is, when we set it to be true, the next time when we check this while exit condition, not true is going to be false. All right, that's about the logic. Let's now trace the code very quickly, just to get it with you. Let's say the user first of all enters 23 over here, right? So initially the valid integer over here, valid integer variable over here, let's say initially is simply assigned to be false, right? And then we can go into the iteration, first iteration, and then the input that user enters will be 23. Let's say 23. Apparently this cannot be converted into some numerical value, so we're going to go for the try block. And then when we try to convert the user input, which is 23 spelled out, and then of course this is going to trigger the exception. So this is going to trigger the number format exception, meaning that we're going to bypass the rest of the try block, and then we'll go for the catch block. And then we're going to signal to the user input, which is 23. So we're going to say 23 is not a valid integer. And then when we go back to the while loop over here, we're actually going to check that valid integer here remains to be false. Not false is going to be true. That means we're going to go for another iteration. All right, so far so good. Let's say we're now going to go for the second iteration, and we're going to enter 23. So for the second iteration, I'm going to use the green. So we're going to say enter an integer second time, and then we're going to have the user input the next line. And let's say this time it's going to be 23. So it's going to be 23 as a string value. And then we're going to execute the try block. And then we're going to say user integer over here is going to be assigned to integer.parseInt. if I say 23 over here, it is not going to trigger the number format exception. Instead, it's going to store 23 into the output as a return value. And then that means we are not going to execute the catch block in this time, right? It's going to be bypassed. Instead, we're going to finish off executing the rest of the try block after this method call, right? So in that case, valid integer is going to be true. Set it to be true. And also, the user integer has been set to 23. Both are good. And then since we ignore the bypass the catch block, and then when we go back to, finally, when we go back to the loop over here to check its exit condition, valid integer right now has been set to true. Not true is going to be false. So that means we'll go all the way over here to exit from the loop, and then we go here, and then we'll just continue with the rest of the program. Right, so that's how it is going to work. I'm just trying to execute on the paper to show you how it will work conceptually, but you're really highly encouraged to really put in the code into Eclipse and try it out yourself, and try to use the debugger to make sure the execution flow for both test cases over here really makes sense to you. Okay, and that's about it for exception lecture, and I would like to mention one more point before I conclude the lecture. Okay, so that's about the example I just showed to you in detail. And beyond this lecture, that's the final point I would like to mention. What should you do beyond this lecture to really reinforce your understanding? I want you to practice creating a new exception class upon a method, throwing it in the body of an implementation, like the one we show in the version 1, version 2, version 3, and also the circle and the bang. You got many examples there to try. Okay, invalid radius exception, and also invalid transaction exception, for example. And then I want you to play with the two Java projects made available to you. You can simply import these two archive files into your workspace. You can simply create another workspace if you like, or you can just use the one that you did for the review tutorial series. This is what I want you to do. You want to really go into the source code made available to you. You want to change the input values so as to explore in the Eclipse debugger, right? I want you to really go slow motion, line by line, step into if necessary, but normally just stack over. You want to really compare the normal versus abnormal execution path. Normal means the exception did not occur, and abnormal means the input is actually invalid, so the exception occur. I want you to really compare how these two execution paths would be different. All right, so that's about the exceptions lecture, and that's about it for this week. I hope you will really understand that exception is quite a tricky topic for Java OOP, but we have to get through it. All right, that's about it. If you got any questions, reach out to me.